Hello, welcome to Chapter 6, Section 6, Solving Systems of Linear Inequalities. Again, we have an application problem which is a step beyond what we've been doing, and it's a step toward where we actually do this in like business applications or engineering applications where we want to optimize our profit or optimize horsepower for building an engine, or like a lot of other places. One of the problems we do in Algebra 2 is where we optimize how much carbon dioxide is scrubbed from planting plants that take out carbon dioxide and increase oxygen. Okay, so it has to do with the environment. So we see these in all different places is what I'm getting at. All right, so we have a business. Sandy sells lemonade and cupcakes. Again, she probably sells something more than that, but we're just going to look at lemonade and cupcakes. She makes $2 profit on every cup of lemonade that she sells. So she probably fills it up with ice. I hate it when stores do that. And she makes $1 profit on every cupcake that she sells. So we got some information here. We're going to come back to it. She wants to sell at least 5 cups of lemonade per day and 5 cupcakes per day. And she wants to earn at least $25 per day. Nothing like setting the bar low. So again, in the real world, we would probably say, well, we actually want to make $25,000 a day, or if it's a small business, much less than that, but a big business, it would be more. So we're going to graph this and find out how many of each she needs in order to meet her goals. The first thing we got to do is we got to talk about what symbol we're going to use. This is called defining your variables. So I'm going to tell the reader, the person looking at this, the audience, I'm going to let X represent the number of cups of lemonade. I'm going to abbreviate because I'm running out of space. Sold. And I'm going to let Y represent the number of cupcakes sold. And I don't like lemonade with cake. I like milk with cake. What can I say? So I'd have to go some other place. The first thing, she wants to make $2 profit on every cup of lemonade. So that's going to be $2 multiplied by how many cups of lemonade she's going to sell. So that's going to be $2 times X. X represents how many cups of lemonade you're going to sell, or she's going to sell. She's going to make $1 for every cupcake that she sells. That's $1 times Y, which is basically 1 times Y is Y, but I wrote it with a 1 so you can see it's 1 times Y. $1 for each cupcake sold. I'm going to add those two things together because they're both going to be cash in my drawer. And it says she wants to earn at least $25 per day. So I want it to be more than 25, but, or not me, Sandy, but Sandy will also be okay if it's actually equal to 25, but not less than 25. If she makes less than 25, she had a bad day. Now, we got some other information. She wants to sell at least 5 cups of lemonade. The number of cups of lemonade has to be more than or equal to 5. She wants to sell at least 5 cupcakes. So the number of cupcakes also has to be more than or greater than 5 or equal to 5. So she'll take 5 of both, but she would want more. All right, let's graph this and see what we can do. And I think I'm going to try to use my other markers here too. So my boundary line is going to be, I'm going to write my boundary lines down here. 2x plus y equals 25. So if I let y equal 0, I get 25 divided by 2, which is 12.5. So my x equals 12.5, which is right here. If I let x equal 0, I get y equals 25. And y equals 25, here's 20, 21, 22, 23, 24, 25 right here. Since it could be equal to that, I'm going to use a solid line. And I'll tell you what I'll do. I haven't done this yet, but I'm going to borrow my protractor here so I can draw a straight line. Boom. And I'm going to shade above. Now, I'm going to show you one thing about the shading, and I should have done this with the other one. I know that I have actually 3 boundary lines, so I'm going to have 3 areas here. So what I'm going to do is I know I want to be above this one, okay, because I want to make more than $25. So I'm going to just put little marks on this side without doing the whole thing. That's just going to tell me that I want to be above that line. When I get the other ones drawn, I know which side of that line to shade. X is greater than or equal to 5. That boundary line is x equals 5. When I draw x equals 5, that's a vertical line that goes through x equals 5. So here's x equals 5, and I have a vertical line that goes like this. And since I want to sell more cups of lemonade than 5, I'm going to be on this side, which is going to be like this. So I'm just going to put little marks to the right of that line, which is going to tell me when I do fill in all my shading, I want to be above this one and to the right of that one. The last inequality is the boundary line is going to be y equals 5. That's a horizontal line at y equals 5. So that's going to look like this. And I want to be above that boundary line. I want numbers that are the y value is greater than 5. So I'm going to be shading this side. All right, so now let's think about this. I'm trying to grab something here. This post-it note will work. I'm going to shade above that line that represents the money. I'm going to be on the right side of this line, and I'm going to be above this line. So my overlap region is going to be this area right in here. And that is going to represent the number of cups of lemonade and the number of cupcakes that's going to meet her requirements. And you can try different things. Okay, it says list 2 possible combinations. So I could list 20 cups of lemonade and 20 cupcakes. All right. Her profit would be $40 plus 20, $60 is more than 25, so that's good, right? And both of them are greater than 5. And then you can pick anything else over in this area. I can pick this one, let's say right here, which is, this would be 12, and this would be, 28. So 2 times 12 plus 24 plus 28, that's going to be more than 25, and both of them are greater than 5. Now, before I stop this video, sometimes there are inequalities that represent, all these represent what we call constraints. Sometimes there are constraints with like things she can't go over. So there may be a constraint with time. There may be, like she cannot make an infinite number of cupcakes. All right? It'd be great if she could. She could sell an infinite number of cupcakes and make infinite money. But there's a time constraint for how many cupcakes she can make in a day. There's also a space constraint. So there's some things that are going to box in this. So it's not going to be like open like it is right now. And if that's the case, then we're like, well, what would be the best situation for what's the most amount of money she can make? And that is called linear programming. And we're setting you up for that because it's a big part of Algebra 2. So I like letting you guys know where things are headed and when you're going to see things again. All right, we'll see you actually, this is the last video for that one, so good luck.